maximum and minimum elements in an array. How to find out a maximum and minimum elements in an array, okay, using the divide and conquer technique. The first thing we did was to figure out the tracing part. I can see very clearly on the screen now that you can see that the first thing we did was, to figure out how to trace this. And we call this as tree of recursive calls. If they ask this question, this is one of the best questions that they can come through. Okay, so what was the first thing? The first thing was the tracing part. Okay, you can see very clearly that we did the tracing. So there was no point in that. And then we sort of understood the way it was all traced and all. We figure out what is low, we figure out what is high, we figure out what is minimum element, what is maximum element, and based on that, we keep on do the tracing part. At the end of it, we keep moving ahead of like this. Once we divided everything, we move ahead and we find out that, the first element will be representing your minimum element. The second element will be representing your maximum element. Okay, you can see very clearly here. Maximum was 90, minimum was minus 9. Okay, this is something which we found out in the previous class. Now this is not going to end here. Okay, obviously there are other two things that needs to be found out based on this. So what are the other two things? The other two things is a very important aspect of figuring out how the algorithm will work, or what is the way of writing an algorithm. Okay, and then the time complexity of it. Now these two things are very, very important aspects. Okay, and there's a little bit of confusions also that are going to creep in here, because we are not going to write an algorithm like how we write in a normal way. Okay, this algorithm is a little bit, better, what you call a confusion side. Okay, so we got to be careful towards it. And one other thing is with regard to time complexity. Again, in there also, there are 1, 2, 3 steps possibly. Okay, 3 steps where you have to be very, very careful of dealing with it. If you are able to do that, then I'm pretty sure that all other things are very much easy to do. Okay, so let's start to and try to do that. Okay, what is a way of doing these things? Okay, so number one, first and foremost thing is to figure out what is the way of writing this algorithm. Okay, so let me write an algorithm for it. Okay, first and foremost, before writing an algorithm, you need to keep in mind that what is the way of things that we have designed. Okay, first and foremost thing is, if there is only one element, okay, in an array, if there is only one element in an array, what is the meaning of that? That one element itself is the maximum element, that one element itself is the minimum element. No confusion in that. Okay, then if there are only two elements, then what you do, you compare two elements, think A comma B. Okay, if there are two elements A comma B, what we do, we compare A with B, right? We always compare A with B. So that's a thing that we do. We compare A and B, and then what we do, some element will be assigned to your whatever the maximum, think A is maximum, that A will be assigned to maximum. And of course, if A is maximum, B will be obviously minimum. Okay, there are only two elements. This is a strategy. If there is only one element, this is a strategy. What's the next thing? Okay, the next thing is if there are more than two elements. Okay, if there are more than two elements, we know the clarity, what needs to be done. What we take an array like this. Okay, we split in such a way that first we figure out the low. Okay, then we figure out the high, then we figure out what is the maximum element in this, minimum element in this, or minimum maximum, however order you want to write. Okay, now with regard to this, what are the ways that you can think? Instead of writing low and high, I can take an individual elements or tracing elements like ing. Okay, so except these things, is there any other things? No. So we are going to write an algorithm basically to work for this, to work for all these three conditions. Keep this in mind that we are going to write an algorithm and also the time complexity with regard to these three conditions. Okay, in algorithm, I will be using I and J. Now, people may be asking why I and J, why not low and high? You can use low and high. Okay, I'm just following the VTU conventions of using I and J. Okay, because at any point of time, we should not sort of deviate from VTU, right? It is something that, VTU is the ultimate, then only the other aspects of it, because there only your results, everything matters, right? So yeah, So let's go and let's look into this. Okay, what are the things to be written? Okay, the algorithm, please understand this is a very important aspect of it. Okay, this is the last part of divide and conquer that you got to keep in mind. Okay, generally they do this, then they move into the next parts, which is merge sort, quick sort, binary search, transcends, multiplication and all. But that's like, people thinking that, this is easy, but I always feel that this is a little bit complicated, because here there are certain things where you got to keep in mind, okay, which are a little bit confusing. Their binary search, merge sort and all is pretty much direct, right? Pretty much direct there. So instead of that, this will be a one that needs to be kept in mind. Okay, so let's start writing an algorithm. Okay, so what will be the algorithm? The algorithm will be basically coming through like this. So I'm going to write it algorithm to figure out what? To figure out max and minimum element. Okay, be careful with the way I'm writing it. Okay, and what are the things that are needed in this? I, be careful here. I will be representing nothing but a low. Okay, then I'm going to write J will be representing your high. Okay, then of course I'll be writing what is the maximum element and of course the minimum element. So once you sort of understood the tracing part of it, this becomes very easy. Okay, how I used to write and all. So for this, how we are going to write it? Okay, see, algorithm is not conventional. It looks more like a program. So got to keep in mind. Okay, so if there are only two elements, sorry, if there is only one element, what is the way of writing it? If I equal to j, if there is only one element, then what do you write? You write, then what do you write? You write the maximum is also equal to minimum is also equal to a of I. Done. Okay. If there is only one element, this is how you write it. Not a problem. If there are two elements, okay, so I can't write else, right? I can't write else. I have to write else if, because there are three conditions. If, else if, and the last condition, of course, will be under else. Okay, else if there are more than one element, if there are two elements, if I equal to j minus 1, okay, which is you are comparing with the first element and the next element. Okay, then how you write it? You write it like this: if a of I is less than a of j. What is the meaning of that? A of j is greater. Keep that in mind. See this? If a of j is greater than your a of I, what do you write it? You write things like this. How? In a way that you can easily see here. Okay, I'm going to represent the maximum element as what? A of j. See this, a of j is greater than a of I. A of j is greater than a of I. So I'm representing a of j as the maximum element. Done. Okay, then what is that? Minimum element will become, obviously will become a of I, right? So this condition is done, but this condition may become false also sometimes. When do you think that will become false? When a of I itself is greater. Okay, when a of I itself is greater, then this condition will not work, right? So you have to write for the next condition for it. So how do you write it? You write it in the else part. What is the else part? You write the maximum element to be a of I. Okay, minimum element to be a of j. Okay, see, that's the end of this one. Now this entire thing, you can see very clearly that I have ended for two elements. Can I go there now? Before we go and write the third element, can I do what is known as the most important part? Okay, what is that most important part? I'll name this. Okay, I'll name this. This is with regard to if there is only one element. If only one element. Okay, this is with regard to if two elements. Okay, if this is with regard to one element, this is with regard to two elements. Now I need to go write it for what? Three elements or four elements or five elements, or in very general way I can easily say more than two elements. Okay, for more than two elements, what is the way I need to write it? I need to go there very clearly and I will be writing things like this. How? Okay, will be 1 second. Yeah. Now I'll be writing. See, I told you very clearly there are three conditions. So the first one you wrote it as if, second one you wrote it as else if, and obviously the third one. Okay, the third one. Okay, I'll write it the same color or in different color just to showcase, that it's a third condition. So else the third part, right? Third part, very clearly how I did the tracing part and all. Okay, we took the array, we split that into half part. Then again we took this, we split it into half parts like this. When again we took this, we split it into half parts like this. So this is what we did. Okay, we keep on, split that into, two parts, two equal parts. I'm going to do the same thing now. First thing is, I am going to take the mid element and I'm going to figure out the mid element, like how low plus high divided by 2. Okay, low plus high divided by 2. So this is easily found out. Okay, the first part is the mid element that is found out. Then the next part. Okay, what is the next part? We need to figure out. See, when we wrote this, what you call the split up into two things like this. Okay, every time we used to figure out what? We used to find out a maximum element here also, minimum element here also. Maximum element was here, minimum element was here, and also in this side also maximum element and minimum element. Like this, we need to figure out, every time we used to do this. Then we used to sort of combine it and figure out what is the maximum element here, minimum element here. Then mix these two things like this and figure out, okay, what is the maximum element here, minimum element here. So to, sort of facilitate this, we are going to take one more element towards it. What is that one more element? Okay. So to make sure that we have both the things being getting merged, we are going to take two things here, two important things here. Okay. So what are the two important things? Okay. So we are going to take max one and minimum one. Okay. We are going to take that. Okay. And what we are going to do? Okay. How we will figure out? Okay. Max min, same old call of recursion call here. We start from low. Be careful here. We are going to start from low up to where? Up to the midpoint. And we figure out what is that. Every time we figure out maximum element and of course minimum element. Okay, I'll just show once again. I'll show the tracing again because I think the tracing been like on Monday, so some people would have forgotten it, right? So I'll just show the tracing. See this? So the tracing part you can see very clearly. Okay, I would have written the same thing. See the low, see the high, the minimum, maximum, and it's been done for each and everything. There's a low, there's a high, minimum, maximum. There's a low, there's a high, minimum, maximum. Like this, we have been doing it for each and everything. Each and every trace, we have done it. Each and every step, we have done it. Okay, low, high, minimum, maximum. Like that, we have done it for each and everything. And you can see very clearly, okay, you can take this example. See, this is low and you go up to high. Here also low and you go up to high. This is again low from towards the right hand side and you go up to the last point, which is high. Like this, we keep on doing things, right? So this is the same old way. I'm going to write it in terms of an algorithm here. Okay, what was, one second, this algorithm? Yeah, very clearly that I'm going to write the same thing right here. This is with regard to the left branch. Be careful here. I'm going to write it again. This is with regard to the left branch. Okay. If there is left branch, obviously there should be right branch. So what is algorithm? Max. Again, you're going to write the minimum part. Okay. From where do you start? From the low point to the midpoint we have done. So obviously we need to start from the next element of the midpoint. So mid plus 1 up to where? Up to high. Okay. We are going to figure out the same thing. But here we have done max and minimum. Towards the left hand side, we have written max and minimum. So towards the right hand side, we are just going to name as max 1, min 1. See, if there's two things which are of the same name, we do the same thing, right? Every time. Even when we are naming a file also, in our computers, desktops, laptops and all, we do the same thing. Okay. 1, or if there is something under your name, you have saved it something under your name. If you want to say the same thing again, what do? You say, your name 1. Okay. Or, 1 with a date like that. Okay. We sort of save it anyway. The same thing I'm doing right here. Okay. Then what's the next thing? Next thing is I need to compare. Okay. That comparison aspect of it is all done here very clearly. Okay. What is it? If max. Okay. And max 1. You're going to compare which one and which one. left and the right part. I told you very clearly when we did the tracing also, you sort of would have seen it. We are going to compare the two maximums, left hand side and also right hand side. And then whichever is greater, that we are going to assign it as max the element, maximum element. Okay, maximum element or minimum element, like that. Okay, we are going to sort of do that. Okay, see this maximum element, if it is greater, it becomes max 1. Otherwise, what you do? Otherwise, you go and check with regard to the minimum element. Okay, minimum element. Sorry, we need to change the sign. Na? Same thing, not. So, if the minimum element, you can see very clearly that, so what is the meaning of this? Thus, the minimum element is greater than your minimum one. So, which basically means minimum one is smaller. Okay, minimum one is smaller. Okay, so that I'm going to write it is equal to min 1. Okay, so I need to close this. And of course, there was one more thing that was open right before we started with the, the algorithm. Is that the end of algorithm? Yes. Did I do anything new? No. Whatever the tracing thing is there, I've written the algorithm for it. Okay. Standard 10 marks question if they ask each and everything. See this? This is the algorithm. If I zoom in through here, this is what the algorithm it is. Okay. What are the various things that you see right here? This is with regard to, the left branch or the right branch, sorry. Okay, this is with regard to right branch. So this is left branch, this is right branch. Okay, this entire thing, what you see probably is nothing but the algorithm aspect of it. Okay, this is algorithm is all done. What's the next thing? Next thing is with regard to figuring out what is known as the time complexity. That's very important again. Okay, that is very important. Any question you take in this model, okay, any question you take in this model, before we write the time complexity, the last part of divide and conquer, please keep in mind of what are the things we have studied. We are talking about divide and conquer, and we started with all what is divide and conquer, everything. In that, we saw various examples. What are the various examples? For each and everything, for each and every of all of these, we saw merge sort example. We saw what is known as a quick sort. Okay, we saw what is known as a binary search. Please keep that in mind. Okay, long back, but again, then we saw what is known as a Starsons, matrix multiplication. The remember, M1, M2 like that. Okay, the matrix multiplication, and of course the last example being the very simple fact that you are going to figure out the maximum and also the minimum element. Okay, maximum and minimum element for all these things. Okay, for all these things, probably what are the things we figure out? The things we figure out was number one, we knew what is the design way of doing it. We knew what is the way of writing an algorithm. We knew about the tracing part. If there is a tracing part, we know the tracing part also. Okay, then of course the time complexity. So these are the things which we have done long back. Of course, we need to write the time complexity for this. We are going to do it now. Okay, see this? This is how you sum up everything. What is there after this that is there in the syllabus? No, nothing. Of course, there is one part which is the last part, which is topological sorting, which probably we are going to do it in a tomorrow's class. But is this the entire second module? Yes. Okay, lots of things to learn. Of course, 5 things to learn and 5 things to be kept in mind. Okay, things to learn and also to be kept in mind. Okay, everything basically belongs to these things only: the design process, the algorithms, okay, the tracing part, the time complexity of this only, everything will be depending upon. Okay, so this you got to sort of keep in mind. Okay, so what are the things to be kept in mind? First and foremost, all these things. Next, the last part, the last thing of divide and conquer. We are going to wind up divide and conquer. So what is it? Figuring out the time complexity of maximum and minimum of the element. Okay, how do you do it? I'm going to do the same old way. Please keep this in mind. This is a little bit confusing thing. Okay, the class will go up to till I sort of end it. Okay, so keep that in mind. In the previous yesterday's class also we lost it because of all that okay. So today's class we need to figure out, okay, and sort of wind it up. So let's do and figure out the time complexity of it. Okay, what is the way of writing a time complexity? First and foremost, you need to know the recurrence relation of time complexity. What is it? T of n is equal to, what are the three things? Three things I'm going to write, okay? The three things I'm going to write. First one, if there is only one element, n is equal to 1. Do you do the comparisons? No. So it's 0. If there is only two elements, n is equal to 2. How many comparisons you do? You do one comparison. There are two elements. Obviously, you need to compare those two elements and say which is maximum, which is minimum. You do that. We always do that. Okay. Then, if there is more than two elements, okay. If there is more than two elements, we need to do the left part. We need to do the right part. And of course, we need to merge both left part and right part. See how I write it. Okay. This is the most important part. Okay. Of remembering things. Okay. So three things we written. Now, what's the most important part? To figure out a time complexity, obviously I can't take, n is equal to one element, n is equal to two elements. I need to take what is known as n is equal to more than two elements only. Because I need to figure out time complexity. I need to go always for the worst case, not for the, the best cases and all. Okay. So I need to go for the time complexity. And where do you start? I start from here. T of n is equal to 2t n by 2 plus 2. What is it? Tn by 2 plus Tn by 2, 2Tn by 2. Okay, not doing anything extra, just starting from there. Done? Let's start doing this. Be careful here. This one is a little bit tricky. Okay, just you got to be careful here. There are 2-3 steps where people will generally go wrong. So I'm saying please be careful with regard to this. Because we are going to get a time complexity which is not generally what we get it in the previous examples, whatever you have seen. This is a little bit tricky, so let's be very, cautious with regard to this. Okay, so let's go this. Okay, if n is equal to 2k, we always take this, nothing new for this. We are going to assume let n is equal to 2k. Fine, that is all fine. Okay, if you have done that, so what is the next thing that is going to happen? The next thing that is going to happen is I'm going to write the things like this. Tn is equal to 2t, okay, and be careful with the way I'm writing this. This will become 2k, okay, because n I have taken as 2k divided by 2 plus 2. Okay, what's the other way of writing it? 2t, be carefully at k minus 1, because 2 when it comes on top it becomes 2 to power of minus 1. Okay, so this will become like this plus 2. Okay, this is with regard to the first element. The first element, this is what you got. Okay, the next element, if you want to write the next element, how do you think this will become? I need to go right for the next element, so I need to subtract for this, sorry, substitute for this. So this will become as what? 2t of 2k minus 2 plus 2 and of course plus 2. See what I have done, I have not done anything new. Please keep that in mind. I have substituted for this, that's all. Okay, I have substituted values for this. Nothing else I have done. Okay, so 2 will remain 2, 2 will remain 2 here. No other change, no other change. Okay, so what is the other way of this as what? 2 square, 2 into 2 is nothing but 4, which I can write it as 2 square, t 2k minus 2, okay, not changing anything, plus 4, see this 2 into 2, 4, can write that as 2 square, yes, plus 2. The same old 2, whatever that is there is coming right here. Okay, not doing anything extra. Then what's the next? This is with regard to what? This is with regard to the second term. Be careful here. This, see, this is with the first term. Then obviously this with regard to second term. Now I need to figure out the third term. So what I do? I need to substitute for this again. Okay, I need to. People might be thinking, why you have to do till 3 terms on the. Why can't you generalize up to 2 terms? No, it's better you do it up to 3 terms. Okay, Don't be that, what do you call, thinking you are for yourself, I'll do it only for 2. No, when they have said 3 terms, you need to go for 3 terms. Listen, okay? Don't be, too stubborn enough to say that I'll do it for only 2. No, 3 means 3. That's all. Okay? There's certain things you question, don't question, right? So what's the next? What is the next thing? We are going to again do it for the one more term. One more term means cap that you are going to write again 2 square. Okay. With regard to this one. So what will this become? It will become 2t of 2k minus 3 plus, of course, okay, sorry for the disturbance. I hope you're back. Okay. Again, this is a problem with regard to the power connections and the internet connections in India. Okay. No matter what they say, connection, the quality of connections is always poor. Right? Hopefully you're back. Yeah. So this is with regard to figuring out what? The third term. So if I'm going to write the third term, this is how it will be. See again the same old thing, 2t, 2k minus 2 plus 2. I've written the same thing here, 2t, 2k minus 3 because we are figuring out the third term plus 2. I'm writing the same thing, nothing new. Okay, there is no new thing here, just same old thing. Okay, then I write the same thing here. What is that? 2 square plus, not just 2 square, be careful here. Is it only 2 square? Yes, only 2 square. 2 square plus 2. So if I simplify this, what is going to happen? This will become like this 2 cube, okay, t of 2k minus 3, okay, plus 2 square into 2. Be careful there, it is nothing but 2 cube plus 2 square plus 2. This is what? This is with regard to the third term. Okay, this is with regard to the third term. You figure out the. Now we have figured out till third term. What is the next thing? Next thing is to write a generalized version. This is where you got to be a little bit careful. Okay, you need to write the what is known as a generalized term for it. So if you go for a generalized term, or in what we call it as up to ith term. So how do you think this will become? This will become like this. Okay, I'm going to write for the ith term. Be careful here. Okay, I'm going to write the in a way like this. What is it? Equal to 2 to the power of I, because I'm going to write up to the ith term. Okay, ith term. So instead of 3, 4, 5 like that, I'm going to write in general I. Okay, t of 2k minus I. Why I've written k minus I? Because see, I've taken 3 as I, like that you can think. Okay, 3 as I, so k minus I plus 2 to power of I plus 2 to the power of I minus 1 plus 2 to the power of what? You have to take it as in terms of this itself, or you can just keep it as 2 because there's no term here, so you can just keep it as 2. Okay, this is with regard to up to writing the ith term. Be careful, it's up to the ith term. This is step number 1. I'll say this is a easier version. We don't have to worry. But the next step that is going to come. Okay. The next step that is going to come will become very, very important. This is where I say, people, be careful. Okay. What is that? We are going to take, okay. So this step is very, very important. Please keep this in mind. Okay. Something you mark it there now that you know it is important, something like that. Okay. So we are going to take I is equal to K minus 1. See, why we are going to manipulate all these things is to make sure that we get our time complexity. Okay. So we are going to take I is equal to K minus 1. If we take that, what is going to happen? This entire thing, what is the equation going to happen? 2K minus 1, because I have taken as K minus 1. Okay. So you can see very clearly there's 2, I my 2 to power of I has become 2 to power of K minus 1. T, same thing, 2K minus K minus 1, okay, plus 2 to power of K minus 1. You can write like this for everything, or you can just write up to the last term, which is 2. Okay, this is the most important part. This is the most important step, one of the most important step, not the most, one of the most important step here. The next thing, okay, the next thing is to figure out the next terminology. What is the next thing? Okay, 2 to power of K minus 1. Okay, and this, be careful here. What is this going to happen? T of 2 to power of K minus K. So T power of this will not go. Okay, then this will become just 2 to power of 1. You simplify this, you will easily be able to understand. Okay, plus 2 to the power of K minus 2. What is the way of writing it? 2 to power of K into 2 to power of minus 1. Okay, and comes on top, it can easily become minus 2. Okay, then the next terminology. The next terminology, be careful with here again. 1 second, I'll move the screen. Yeah. So what is the next thing? Okay, the next thing, be careful with the way I'm writing this. Okay, 2 to the power of K minus 1. Okay, and this entire thing, T 2 to power of R. What is it? I can easily write this entire thing as into 1 plus 2 to the power of K minus 2. Now what is it? This is because of a very simple fact of 2 to power of 2, T of 2 is nothing but equal to 1. When there are two elements, what is the number of comparison? It is nothing but equal to 1. I would have written this. Okay, I would have written this in the recurrence relation. Okay, I would have written this in the recurrence relation, though this is what it is. So T to power of 2, T of 2 is nothing but equal to 1. T of 2 is nothing but equal to 1. Okay, so that's the next one. Next one is, how can I write this next one? 2 to power of K divided by 2. Okay, what is the way of writing it? 2 to power of K and minus 1, I have written it as divided by 2. When you take on top, obviously it is 2 to power of K minus 1 only. Okay, plus 2 to the power of K, same thing, minus 2. Okay, just the same old thing of I'm writing it. If I go write the next statement, what is this going to happen? 2 to power of K plus 2 into 2 to the power of K. Okay, divided by 2 minus 2. What did I do? I didn't do anything. 2 to power of K multiplied this 2 into 2 power of K. So whole divided by 2 minus 2. Okay, then what is the other way of writing this? I can write this as, see this is 2 and this is 2 into 2 power of K. So I can write this thing as 3 into 2 to the power of K divided by 2 minus 2. Okay, this is the next important step. Okay, which one? This whatever I took, the transformation I took. This is the next important step of where you people will generally go wrong. This step, okay, is very important. Okay, this is very important of why I have taken 2 power of k divided by 2. Because 2 to power of minus k minus 1, I have taken this as 2 to power of k divided by 2. Okay, so this is what I have taken. The next step, the next important step of where do you think this will become very important? Okay, the next step is how I'm going to write this. We are going to again put back, be careful here. We are going to again put back whatever the thing we have taken in the first step. We are going to put back 2k as equal to n. We took n is equal to 2k, right? And like that only we have done all the simplification. So we are going to put back 2k is equal to n. If you do that, what is going to happen for this? Wherever you got 2k, that will become n. So this will become 3 into n divided by 2 minus 2. What is the change I made? The change, very simplest of change I made was to just put back whatever we had taken. What was that? This one. Wherever you got 2k, I have put back as n. So this became as 3n divided by 2 minus 2. What's the other way of writing it? 3n by 2 minus 2. T of n. What is the third thing I told you where it will become important? The third important thing which you know it will become important is right here. So 3 places will people will generally go wrong, or they will not get to know what needs to be done next. This is where the 3 steps. Okay. And what is the time complexity you get? This one. This is the time complexity of figuring out what? Figuring out the maximum and minimum element of an array element. Okay, an array elements using your divider is nothing but the time complexity. What is the time complexity of it? The time complexity of it is nothing but equal to 3n by 2.